Hello students, so we are going to discuss the next paper, right? So let us start that. So this is the 21st January 26 evening shift, right? So let us start with the question number 1. So first question, there is a circuit given, there is a circuit given, right? So this is the electric circuit. What is given in this? In a circuit, there is a battery with internal resistance R and EMF E which is connected to external load resistance, right? Find value of R so that maximum power dissipate across R. So they are asking to calculate the maximum power, right? What should be the value of this capital R? Find R value, capital R, so that maximum power is generated in the circuit, right? So this is a very standard condition. We know that already. We do not have to solve anything in this, right? So the condition for maximum power, for maximum power in the circuit, in the circuit, capital R must be equal to internal resistance. We already know this. This is an important condition. But suppose if you do not know how to solve it, so you know the power formula, power is equal to, we can use I square R, V square by R, anything. But here we have to see power in this branch, right? In the external resistance. The power we can write as I square into R. What is I? I will be the current which is passing through this, right? So now this internal resistance, this internal resistance is small r and I is the current. So can we calculate current first? So current I is equal to EMF by R plus R, right? We can substitute that. Let us substitute that. So E square divided by R plus R whole square into R. Now see here the variable is capital R. Power we can differentiate power with respect to capital R, and the condition for maximum minima is that the slope will be 0, right? So dp by dr should be 0, and when you solve it you will get the condition that capital R is equal to small r. That's a standard condition, and the same condition is also true for maximum current, right? If current is maximum, so power will be maximum. Similar conditions are there, right? So let us move to the next question, question number 2. In question number 2, they are asking that there is refractive index, there is a prism, and this angle is given as 90 degree, and there is a ray of light going. This is the angle of incidence, right? This is 45 degree given, so definitely this is also 45 degree isosceles prism. Question is what? Question is refractive index mu of the prism is root 2. Prism has got refractive index mu 2. What should be the angle of incidence? We have to calculate angle of incidence such that emerging ray grazes out of the surface. So emerging ray, suppose this ray is going like this, emerging ray should graze out of this like this way. Emerging ray is grazing out, okay? Emergent ray. So for this ray to graze out, what is value of phi? That is the condition. So directly we should think of drawing normal here, right? Oh, this normal meets, and you know that if this is R1, this is R2, and this is 90 degree, correct? This 90 degree means this angle of emergent become 90 degree. So we can apply Snell's law, and anyway we know that here this angle R2 must be the critical angle. R2 is going to be critical angle, right? How much will be critical angle? Mu is given, critical angle is what? Critical angle is Sine of critical angle is 1 by mu. So this is sine inverse of 1 by mu, right? So sine inverse of 1 by root 2. That means it is 45 degree. So once we know that this angle is going to be 45 degree, then from here we know R1 plus R2, and that is given here as how much? R1 plus R2 is angle of prism, right? So what kind of prism it is? They have already given that the angle is 90 degrees. So from here, what will be this R2? R2 we have already calculated. R1 will be how much? This is R1 is also going to be 90 degree. Yes. What should be the angle of incidence of the light rays of that emergent ray grazes out? Now let us calculate that. What should be? So do we need to calculate here, because we know this is by symmetry, this is 45, 45, right? Sorry, this is 45. R1 is going to be 45. So that means we don't have to do any calculation. This will be 90 degrees. Symmetricity is there both sides. That means if this is critical angle, this also will become 90 degree. No need to do any calculation, right? Let us move to the next question. Question number 3. A block of mass m is at rest with respect to hollow cylinder. So there is a hollow cylinder, and this cylinder has got an axis of revolution. This is rotating, right? It's a hollow cylinder, and there is a block which is resting here, right? This is a block. Now this block, what is the question? Minimum coefficient of friction. So friction will be acting like this way, you know that, and weight will be acting like this way, and there will be a normal contact force like this. These are the three forces going to act on the body, right? Now it is rotating, right? Is there any angular speed? Omega is the angular speed, radius is r. They have given all this information. They are asking the minimum coefficient of friction. So we know that if it is going like this, then friction must be balancing the weight, correct? Right now friction is balancing the weight, and also this normal must be giving the centripetal force, which you can write as m omega square r, right? And we should also know that this friction must be less than maximum static friction, right? So this friction is mg is mu times normal, then mg is less than equal to normal is m omega square r. Cancel out this, then what is mu is greater than equal to g by omega square r. So minimum value will be what? Minimum means what? Minimum means it is greater than equal to this, means this equality means that is the minimum value, right? So minimum value will be, minimum friction coefficient will be g by omega square r. Okay, fine. Let us move to the next question. Anyway, this is also an important result in that. Let us go to the next question. Question number 4. In a meter bridge, two balancing resistances are given. So there is a meter bridge is given. Meter bridge experimental setup is given. And this is the 1 centimeter wire, right? This point you can take AB. Then this battery is there, right? And there is a galvanometer connected with this jockey point. This point is P, you can take. Here they have given this resistance is 30 ohm, this is 20 ohm. Okay, then what is the question? Galvanometer shows zero deflection for the jockey point P. Okay, then find the length. So this length AP, this is, let us say x, this becomes 100 minus x in centimeter, you know that, right? So they are asking this length, balancing length x. We can easily take ratio calculate, right? So 30 by 20 is equal to x by 100 minus x over, from here x you have to solve it, that's all, right? So solve it. So 300 minus 3x is equal to 2x. 5x is equal to 300, x is equal to 60 centimeter. That's all. Fine, let us move to the next question. Question number 5. Two spheres having equal mass. Okay, charge q and radius r are moving towards each other. So there are two spheres, they have same mass, they have same charge, right? They have same charge, they have same radius, are moving towards each other. Both have same speed, so they are moving towards each other. So let us say that this is the center, so they are moving towards each other with a velocity u. Okay, with a velocity u at an instant when distance between their centers. So right now the distance between their centers, center to center distance is 4r. 4r. Okay, the question is minimum value of u so that they just touch each other. They have to just touch each other. So when they are going to touch each other, what happens? Distance between their centers will become how much then? Yes, distance between their centers r 2r. Correct. So when they are going to just touch each other, the distance between their centers will become 2r. And we have to find the minimum speed. So when they just touch each other means their speed now becomes 0. Both of them are going to stop, right? So here we can use energy conservation because there is no friction forces and any other thing. We can apply energy conservation. So initially they have kinetic energy, so half mu square, and two bodies are there, so multiply to total kinetic energy. What about the potential energy? Potential energy is how much? Half. Potential energy means electrostatic potential energy. So let's write electrostatics potential energy. Yes. How much will be the electrostatics? K Q1 Q2 by distance. Distance is 4r. Finally, kinetic energy is 0. Potential energy is again K Q1 Q2. Now final distance is 2r. 2r, right? So total energy you have to balance. Initial kinetic energies of 2 plus potential energy is interaction between two. So k q1 q2 by distance, right? Like this you do. So from here what we want to calculate? We want to calculate u. You calculate. So from here solve. 2 to get cancel, mu square. Solve it. So kq square by 4r. So from here u square becomes kq square by 4mr, right? K you substitute as 1 by 4 pi epsilon naught, right? Substitute. So 1 by 4 pi, that means 16 will come, pi epsilon naught mr q square, right? So u will come under root, or you can write this as q square by 16 pi epsilon naught mr. Fine. This is the minimum speed with which it will be coming. Okay, let us move next question. Next question number 6. RMS speed of hydrogen oxygen. So we have two gases, hydrogen and we have oxygen. Two gases, their RMS speeds are same. So VRMS formula, tell me VRMS formula, root under 3RT by M. Right, if it has to be constant, then temperature and mass should be same. Not exactly, but their ratio must be same. So let us write this temperature of, let us say this is first gas, this is second gas. So temperature T1 by molecular mass M1 is root under T2 by molecular mass M2. Correct? Because they are same, so this ratio has to be same. Right? What is the question? If the temperature of oxygen is 23, find the temperature of hydrogen. So this temperature of this gas oxygen is given as 23 degrees Celsius. So 23 plus 273 becomes how much? 296 Kelvin, right? 296 Kelvin. Now we have to substitute here and solve. So root also gone. So T1 becomes M1 by M2 into T2. So M1 first oxygen hydrogen 2 oxygen 32, temperature of this 296, right? Temperature will come in Kelvin and the option is in degree Celsius. We need to solve in degree Celsius. So try to cancel out some factor here. Here 216 and then can we cancel out 4? 4 4 16, 4 7 28, 4 4 16 getting cancelled, right? Still it will get cancelled, right? How much? 2 2 2 3 2 7, then it will come 18.5 degrees Celsius, correct? Or in Kelvin, it is Kelvin, not degrees Celsius. Now we have calculated in Kelvin, so the temperature is in Kelvin. Note the temperature is in Kelvin. If you want to convert degrees Celsius, so options are given both in Celsius and Kelvin. Okay, so carefully we have to choose the option, right? Let us go to the next. Question number 7. For the given circuit arrangement, so there is a circuit given 2.5 volt and there is 1 ohm, then there is another capacitor is given, then there is a resistance, then there is a diode, here also some resistance is given, then there is a diode like this way, okay. So the values of these resistances are given. This is 2.51, this is 2 ohm, this is 3 ohm, this is 4 ohm, and this is 5 microfarad. They have given. Find the charge on the capacitor in steady state. Capacitor here, what is the charge in steady state means what? Steady state means that there won't be any further current in that, it won't charge further, maximum charge, right? So that means what happened now, there is no current here, you can disconnect this one, right? There is no current here, so that means you have to only consider this circuit. And this is higher voltage, so this reverse bias current will not be there in this you can remove. Is reverse bias, this is forward bias, so current is only going in this. So whatever current is coming, it is flowing only in this circuit, right? Current is just going in this circuit. Okay, let us say current is I. So how much that current will be? This current, first you calculate this current. So current I is equal to V by R. So voltage of this circuit is 2.5 and resistance equivalent will be 3 plus 1 4. 4, correct? We got this. So this is nothing but 5 by 2, 5 by 8, right? Ampere. So we got the current. Now once we got the current, what is the potential difference between these points, right? What is the potential difference between this point? This potential difference first we should calculate. How much will be the potential difference between this? So potential difference between this is going to be same as potential difference between this, or potential difference between this. This potential difference easily we can calculate I into R, I into R. So this potential difference V is equal to, this is potential difference V is I into resistance, which is 3. Or you can also calculate this as the terminal voltage of the cell, EMF minus IR. So why do you want to do that? Directly you calculate. I you have calculated 5 by 8 into 3. So 15 by 8 volt. Correct? Right? We have got this voltage. Then what we need to calculate? Charge. This charge which we want to calculate. Now note that here there is no current in this branch. In this branch current is 0. In this branch current is 0. Why? Because it is in steady state. So that means the voltage difference between these 2 points is same as voltage between these 2 points. Why? Because there is no current, so there is no voltage drop. So potential of this point and this point is same. Okay, so potential difference between this and this is same, right? So that is the same voltage difference V. So Q is equal to C into V. use this formula. So 5 into 15 by 8, and this will be in microcoulomb, right? So 75 by 8 microcoulomb. Nearly 9 point something will be there, right? Anyway, the answer is given as fraction only, so that is the answer. Fine. So let us move to the next question. Question number 8. An electron in a hydrogen-like atom has energy equal to minus 0.04. Okay, E naught is magnitude of energy in of this electron in ground state if angular momentum. So what they are saying here that energy of electron is minus 0.04 E naught. E naught is the magnitude of energy in the ground state, which we know already. No, 13.6 electron volt we know in the ground state magnitude. They are saying that angular momentum of this electron is L. Then, so they are asking you to calculate 2 pi L by h, this value, angular momentum. So first of all, you find out which state it will be, because we know the formula for energy. Energy is minus 13.6 z square by n square. Anyway, z is 1 here. Minus this 13.6 is like magnitude of energy in the ground state. So this is like E naught. Z is 1 and and this is n square. And this E they have given here. Let us substitute 0.04 E naught. So from here minus minus cancel, E naught cancel, n square becomes 100 by 4. That means it is 25. So n comes out as 5. Once you got n, then you know the angular momentum is nh upon 2 pi. So L is equal to 5 into h upon 2 pi. And they are asking you to calculate 2 pi L by h, which is equal to 5. Right? So that's the answer. Let us move to the next question. Question number 9. Question number 9. During SHM, kinetic energy of particle in SHM varies with frequency. So kinetic energy in SHM, its frequency is given. Its frequency is given as 176 hertz. Then question is find out the frequency of SHM means what? Frequency of SHM means how the displacement is oscillating. So displacement means x position. What will be the frequency of x? Its frequency will be how much? That is the question. So kinetic energy, it is a sine square or cos square function. So the frequency of sine square cos square function is double than sine or cos function. This idea we have. So frequency of this and frequency of this, when you compare, this is sine function, this is sine square function. Sine square function has double frequency, right? So frequency of this will be half 176 by 2. So frequency of this is double, so this frequency half of that you calculate, right, to 88 hertz, right? That's the answer. Let us move to the next question. Question number 10. Position x of the particle of mass 2 kg varies. So position versus time equation is given, t square plus t plus 1, right? Find out work done on the particle from t1 equal to 2 second to t2 is equal to 3 seconds. So 2 second to 3 second, what is the work done that they are asking to calculate? So work done by this force, right? Force is acting, according to that position is changing. So first you can think in terms of kinematics, or you can think of work energy theorem. So work energy theorem will be better because that involves change of kinetic energy, right? So mass of the particle is also given, that is 2 kg. So apply work energy theorem. So first calculate velocity dx by dt, differentiate, so 2t plus 1, right? So initial velocity v1 2 substitute 2 to 4 plus 1 5. Now final velocity 3 into 2 6 plus 1 7. So velocity changes. So work done is nothing but change of kinetic energy. This is work energy theorem. Apply that, half m v2 square minus v1 square. Solve out this. So work done will become how much? Solve. Half mass is 2 and v2 square 7 square minus 5 square. Solve it. 2 2 cancelled, 7 square, or a plus b minus b, so 7 plus 5 12, 7 minus 5 2, so 24 joule, right? That's the answer. Let us move to the next question. Question number 11. Find magnetic field at point O in the figure. So there is a circular loop is given, and they are saying that there is some current passing as I in this straight wire, and there is also a current passing in this loop in this direction, right? So they are asking to calculate at this center. Okay, at the center, what is magnetic field? Radius of this is r. So how do you calculate magnetic field? First of all, this is a very long wire. So due to a long infinite wire, you can use the formula, and due to a circular loop at its center, use the formula, right? So only thing is that you need to see the direction of magnetic field, right? If the magnetic field is same direction, then you add. If magnetic field in opposite direction, then you subtract. So let us say that this is the first and this circular wire is second. So due to this wire, apply right hand thumb rule, right? That side magnetic field is coming outward, so b1 will be coming outward there, that is b1. What about b2? This is clockwise. Clockwise means it is going inside, so b2 is going to be cross, right? So now you calculate and see which is larger, then larger minus smaller you will do, right? So b1 you calculate first. So due to this formula, what is the formula? Mu naught I by 2 pi, distance is r only. Now due to circular wire, mu2 mu naught I by 2r, 2 times radius, correct? That's all. Now what we need to do is, we know that this, because of pi, this is going to be smaller, right? So b1 is smaller, so net magnetic field is going to be cross. Why? Because this is large, this is small. This is going to be large because here denominator is smaller, correct? So net magnetic field will be cross, and calculate. So you can take mu naught I by 2 are common, so 1 minus 1 by pi, correct? That is the net magnetic field. Fine. So let us move to the next. Question number 12. Two physical quantities x and y are mentioned. So x is given and y is given. Their values are given 23.01 and another is given 37.3. They are asking what will be x plus y. Note that they are not asking you to simply add this, okay? You need to see the rules of significant figures, or how to take the sum in the resultant when you are adding two numbers and the scientific figures, what will be the final result. So you need to think of with what result is applicable, what rules are applicable in this, right? So you are doing addition. In addition and subtraction, what you need to check? What you need to check? You need to see what? The decimal places, right? Decimal places, whichever has minimum decimal places, you have to keep the same minimum decimal places in the result. But that you will do after rounding off. First you add them. Let us add them. Okay, so first you add them. Normally when you add them, what will you get? Right, decimal, you will get 3 1 and you will get 0 3 and 60.31 will come, but you need to keep up to minimum decimal places, and here after decimal 1, here after decimal 2, so you need to keep minimum decimal place 1. So you need to drop this you need to drop, and if you are dropping this, there won't be any changes here, right? Because this is less than 5, so 60.3 only will remain, correct? So the answer will be 60.3. Clear? Let us move to the next. Question number 13. Question number 13. This is a statement based question. So statement 1. What is statement 1? Statement 1. Statement 1 is saying that in YDS, if distance between slits and screen increases, fringe width. Fringe width increases. So fringe width formula, you know, fringe width beta is equal to lambda d by d. Okay, so they are saying that if the distance between these slits, that means d, slits and screen, capital D increases, then beta increases. Correct? That's right. Correct statement. Statement 2. What is statement 2? Statement 2. Second statement, if wavelength of light used in this YDS increases fringe width. Fringe width also depend on wavelength. We know that lambda d by d. So lambda increases, beta increases. This statement is also right. So if you know this formula, then you can able to judge them, right? Both statements are correct. Let us move to the next. Question number 14. In this question, again, this is an electrical circuit based question. So you can see that current electricity is a high weightage topic. We are getting more questions on that, right? Either it is a capacitive based or resistance based circuit. Okay, so this is 2R, this is R, and this is X. This point is A, this point is B. What is the question? For the given resistive network, the net resistance across AB is also X. Then find. So net resistance across AB, equivalent resistance R equivalent is also X, and this is also X. Note that, and then we have to calculate X. So first of all, this is a simple circuit, right? This is series, means this is 2R plus X. Now this and these are parallel. So what will be R equivalent? Directly you write R equivalent. R equivalent is R into 2R plus X by R plus 2R plus X. You can write like this. And this R equivalent is also X. Now we have to solve this. Let us substitute and solve. So X is equal to R into 2R plus X, and this will become 3R plus X. Now open this, cross multiply. So 3XR plus X square is equal to 2R square plus RX. So X square, it will become quadratic in this, right? Plus 2XR minus 2R square is equal to 0. So solve this quadratic equation. X is equal to minus B, X is equal to minus B plus minus root under B square minus 4AC 4AC by 2A. Solve out this. X comes as minus 2R. Of course, minus cannot happen, so we'll take plus. 8 plus 4, 12. So 2 root 3 R divided by 2. 2 will get cancelled, and R you take common, right? So this will become root 3 minus 1. Correct? Right? So that will be the answer. Let us move to the next question. Question number 15. Question number 15. Work done in an isobaric process is 100 joule. Okay. So isobaric process. Okay, work done in isobaric process is 100 joule. So a isobaric process is there, and work done in isobaric process is 100 joule. Okay, adiabatic constant means what? Adiabatic constant means gamma. Gamma is given 1.4. Adiabatic constant means gamma. Find heat given to the gas. You have to calculate delta Q. So work done is given, delta Q you need to calculate. Now you have to use the formulas or the laws. Which formula are you going to use? Isobaric process, what happens? Pressure is constant. What is the formula for work done? Work done formula in that case is P delta V or NR delta T. Correct? That's what it is. Hmm. And we need to calculate delta Q. Delta Q, how to calculate delta Q? Can we use the first law? Let us apply first law. Delta Q is equal to delta E plus delta W. Or you can also use, because the pressure is constant, you can use NCP delta T. That may be a better approach. Directly you can use it. Okay. So what is CP? CP, you need to calculate. Gamma is given, then you have to think about that. CP by CV is gamma. So CP is gamma times CV. And what is CV? CV is R by gamma minus 1. Right, so Cp we can use this gamma times R by gamma minus 1 into delta T. And from here we know NR delta T. So NR delta T club together, that is 100, and NR delta T club, that is 100, right? And gamma by gamma minus 1, gamma is 1.4, so 1.4 by 1.4 minus 1, 0.4. Solve it, solve it. So from here to 7, then 700 by 2, 350. Correct? 350 joule. That is the answer. Let us move to the next question. Question number 16. Two cars moving parallelly to each other with the velocity. So two cars are given. One car A, another car B. They are moving with 36 kilometer per hour, and this is 72 kilometer per hour. Okay, right. Its mass m1 is m, its mass m2 is 3 by 2m. Okay, and the distance between them r is 10 meter they have given. Okay, find angular momentum. You have to calculate angular momentum of car A with respect to car B. Okay, this way you need to calculate angular momentum. You have to calculate. How are you going to calculate angular momentum of car A with respect to car B? What is this? This is angular momentum. Angular momentum of car A with respect to car B. Now, angular momentum, and that also relative angular momentum. So, do we need to subtract angular momentum of A minus angular momentum of B, or do we use the definition of that, right? So, we must try to use the definition of angular momentum, or you see that the observer is at B, because you have to study A, right? Angular momentum of A with respect to B. So, observer is at B. Observer is at B, and observer will study A. So what will be the relative velocity of, right, B, A with respect to B, right? So what is the velocity of A with respect to B? This velocity you calculate. This is velocity, and this is R position. This vector is R vector, right? This vector is R vector, and this is relative velocity vector. So what is that relative velocity? Let us calculate this velocity. So first you should know that this velocity is in meter per second. You convert in SI unit. So 36 into 5 by 18, right? It will become 10 meter per second, and this is doubled, so this become 20 meter per second, right? So when you calculate velocity of A minus velocity of B, how much it will come? Velocity of A minus velocity of B. So this is 10 minus 20. This is coming minus 10. Minus 10 means what? Minus 10 means relative to B, it will be that side. Okay. So relative to B, A is moving this way. This is what it is. A with respect to B. Minus 10 means it is going that side. Okay. Right. Now, what is angular momentum? Angular momentum formula is what? Angular momentum is r cross p. This formula is there, r cross p, angular momentum, right? R cross p. Now here when we write r cross p, note that this r cross m into v vector. This v vector here is the relative because we are taking all calculation relative. Okay, so moment mass we have to use that mass only, m1 only here, and this is velocity of a with respect to b, right? R vector is given already. So you can also apply right hand thumb rule to see that, because this relative velocity is in this way, right? Relative velocity is coming this way, r is this way. So r cross p, you can see this is r vector and p vector is this way, so it will be coming outward, correct? Anyway, they are asking the magnitude, so magnitude means just you have to multiply, right? R, and they are perpendicular, so rp, r into p, sine 90 degree one, right? So just multiply that. Okay, so r is given 10, mass of m1 is m, and relative velocity you have calculated how much, magnitude 10. Okay, so how much this will be coming, this is coming as 100 m, right? Now here there can be a big confusion. Relative velocity, should we write this as angular momentum of A minus angular momentum of B, like this, where I will write r cross momentum of this, r cross this? No, you should not do. This is not the definition of that. Okay, angular momentum of A cross B is not defined like that. Okay, relative angular momentum, when you are calculating here relative angular momentum of A with respect to B, so r vector is this, and like this you have to. So relative momentum means the observer is here, and based on observer he is seeing the velocity. Okay, and according to that you have to calculate. Fine, so let us move to the next question. Question number 17. In the given LC circuit, so there is a LC circuit is given. This is L, this is C, right? Plus minus charge is Q naught, they are saying. So in the given LC circuit, charge on the capacitor is maximum. So time zero, charge is maximum charge, maximum. This maximum charge is given as Q naught. Okay. At which, find time at which charge become 25% of initial value. Now they are saying that find that time where charge become 25% of Q naught. That means 1 by 4th of that. 25% means 1 by 4, right? So how is charge changes? So in LC oscillation circuit, you should know the formula. The formula, if you don't know, then this is the problem, right? So you must know all the important formulas and all the important topics, then you can do substitution and calculation, right? So LC oscillation charge formula is Q naught cos omega t, because they have given a time zero, charge is maximum. So just like in oscillation, displacement is maximum initially, means it is starting from extreme position, like that. Extreme position means this is the cos function, right? So time zero, it is maximum. Now you think about it, what they are asking time, so you have to substitute this. Q become Q naught by 4, this is Q naught, and this is cos omega t, this got cancelled, right? So from here omega t become how much, 1 by cos inverse 1 by 4, correct? Time we can calculate, but what about omega? Frequency formula also you should know. Omega is equal to 1 by root LC, right? So let us then substitute here. So time will become 1 by root LC, because omega will go denominator, cos inverse 1 by 4, right? Cos inverse 1 by 4. This is the answer. Omega will go denominator, so this will become, this is omega. Let me write one step. Omega will come here. So omega is 1 by root LC. So root LC will come in numerator. Correct? Correct. So omega will go in denominator. Omega is 1 by root LC. So root LC will come in numerator. So you have to match with the options, right? Then let us move to the next question. Question number 18. A boat crosses a river 200 wide. So there is a river which is 200-meter wide, and a boat is crossing in minimum time. So note that in minimum time, the relative velocity, that means velocity of boat with respect to river, this will be that, and velocity of river is like this. So relative velocity is like this. So then only it is able to reach in minimum time, but it will not come here, it will be landing somewhere here, which is called drift. This is called drift, right? This is the direction of the velocity of boat. Now the question is what? These are all vectors, of course. What is the question is that find the time taken to cross the river and displacement of the boat. They have given the velocity of this river is 10 meter per second. Okay. Still water. No, velocity of boat in still water they have given. Note that velocity of boat in still water is relative velocity. So river velocity is 5, and this relative velocity they have given as 10 meter per second. Now the question is, we have to find the time taken to cross and displacement. Displacement, note they are asking displacement. Displacement means initial and final position, not the drift. Okay, so this and this is a vector. Okay, so you can find its magnitude, that is displacement. Okay, so drift, of course you have to calculate. First you calculate time. So time taken is equal to distance 200 divided by speed, same direction, right? Same direction, distance by speed. Time is equal to distance by speed. So 20 second you got distance by speed. Once you got, so drift is equal to, in this direction is speed 5 into time 20. Correct? That means this become 100. So this is 200 and this is 100. So how much this will be? Displacement will be how much? Displacement is hypotenuse, 100 square plus 200 square. So 100 root 5, correct, meter. That is the answer. Let us move. So time is 20 second and this is 100 root 5. Let's move to the next question. Question number 19. Question number 19. In the diagram given below, pulley is a ring. So this is pulley. Pulley is like a ring. Okay. And then what else? They are saying that it is suspended, like this side is capital M and this side is small m. And here there are two rods joined with the pulley like this, diametrically opposite, and this is also connected like this. Let's try to do that. In this diagram, what is happening? This pulley is like a ring, capital M, ring mass. This ring mass is capital M. Okay, pulley mass capital M, and radius is r. Radius of this pulley is r. R is the radius, and they are saying that two rods. These rods have masses mm. How much? Small m. Each has mass small m, and the length is equal to diameter. Okay. Rods rotate with, so rod are rotating with same angular velocity. That means rod is rigidly fixed with the pulley. Okay. Question is find magnitude of acceleration small m. This acceleration. So suppose this is going to go like this way. So this acceleration we can use direct formula. We have to use formulas. We should know. Then only we can solve within 1 minute. There is no need to derive formulas. You can derive, you can waste 5 minutes. You must remember all the important formulas. So you should know that Atwood machine get little bit irritated in the formula. Little bit. Atwood machine formula, you know, m minus m by m plus m into g. But when rotational effect is considered, you have to consider I by r square. Right? You must know this formula. I by r. Now I is what? I is the moment of inertia of the system. The system. So I you should calculate now. I is the ring. This is a ring and two rods. Okay. What is ring moment of inertia? A ring about its center mr square only. That is due to ring. And due to each rod about its center ml square by 12. So ml square. Length is how much? Length is 2r. ml square by 12, and two rods are there, so we'll multiply with 2. Okay, so calculate this how much? mr square plus 2 into 2 4, right? 4 will get cancelled, so 2 by 3 mr square it will come. So here you can take LCM 3, r square you take common, so capital M how much? 3 times. 3 times capital M plus 2 times small m, right? We'll get this. Now I by r square will be this term. Substitute here. So you got the acceleration, right? So acceleration come as m minus m divided by m plus small m plus how much? Do this. Do this calculation. 3m plus 2m divided by 3. Now you finally solve it. G is also multiplied. Okay. So 3 times m minus m into g divided by 3 capital M, 3, 3, 6 capital M, right? And 3 small m plus 2, 5 small m. This is the answer, right? Fine. Let us move to the next question. Question number 20. 20 is not given. Let us move to section B. Section B is also questions are not there. Okay, so I hope you got the idea of solving problems. Questions of JEE Main are not difficult. What is important is to remember all the important formulas, important results, some case studies which will directly fit into the problems of JEE Main, right? So thank you all for your attention. Then we'll see in the next